This is a cumulative bar graph. For X, number of bottles unsold in the month of January is 37. In the month of February, it will be 84 minus 37. March, it will be 144 minus 84. Similarly for Y and Z. Now going to question number 1. Number of bottles unsold for January is 60. If I'll take the data for Z. Now question says that we have to maximize the number of bottles manufactured in the month of January for Z. Now maximum value of manufactured bottles for each day can be 5. So maximum number of bottles which can be manufactured is 150. Number of bottles unsold is 60. So that means we have to maximize the number of bottles which are sold. So it should be 3 per day, that is 90. Now for manufactured 5 and for sold 3 is already used, so it cannot be used for Y in the month of January. So looking at this thing for Y in the month of January. So let us assume that 4 bottles of Y were manufactured on X days and 2 on 30 minus X days. Similarly, 1 bottle sold for Y days and 2 bottles for remaining 30 minus Y days. So total number of bottles which were left unsold for Y in the month of January will be number of bottles manufactured minus number of bottles sold. On solving this, now from the bar graph, this value is given as 53. Now we have to find least possible number of days on which 4 bottles of Y were manufactured, which is X. So we have to minimize the value of X. So for minimizing X, we have to maximize Y. So maximum value of Y is 29, which gives me minimum value of X as 12. Now going to next question. Maximum possible number of days on which 5 bottles of Z were manufactured over the period of 3 months. Now writing the data for number of bottles unsold in the month of January, February and March. These are 60, 46 and 60 respectively. Now for January and March, number of bottles unsold are 60 in both cases. So maximum possible number of days on which 5 bottles of Z were manufactured. For January, it can be 30 days. And for March, it's also 30 days. Now we have to find the value for February. A number of bottles manufactured is equal to number of bottles left plus number of bottles sold. Now for February, assume that 5 bottles were manufactured on X days, 4 on Y days, and 2 on 30 minus X minus Y days. So total number of bottles manufactured will be which is equal to 3x plus 2y plus 60. Now number of bottles manufactured is left plus unsold. Number of bottles left is given as 46. Now since we have to maximize x, so we have to maximize the number of bottles manufactured. So to maximize number of bottles manufactured, we should maximize the number of bottles which are sold. So it will be equal to 3 bottles on every day in the month of February. That means 90 bottles. So which will give me the sum as 46 plus 90, 136. So solving this, 3x plus 2y is equal to 76. Now we have to maximize x. So maximum value of x will be when y is equal to 2. That is, x is equal to 24. So maximum possible total number of days on which 5 bottles of Z were manufactured will be equal to 30 plus 24 plus 30, that is equal to 84. Now moving on to next question. Minimum possible number of days on which 5 bottles of X were manufactured over the period of 3 months. Now again, manufactured is equal to left plus sold. Assuming that 5 bottles were manufactured on X days, 4 on Y days, and 2 on 90 minus X minus Y days. We are taking the data for all 3 months. So in 3 months there will be in total 90 days. So total bottles which were manufactured will be this is the total bottles which were manufactured in this. So now we have to minimize the value of X. So to minimize the value of X, we have to minimize this total value. Now number of bottles which were left unsold. This value is a fixed value which is given as 144. Now to minimize this value, we should assume that every day 1 bottle is sold. So in total 90 bottles were sold. So minimum value of bottles manufactured will be 144 plus 90, which gives me 3x plus 2y as 54. Now I have to minimize the value of x. This will be minimized when y is equal to 27. So minimum value of x here is 0. So answer for this question is 0. Now moving on to the last one. It says Ratio of number of days on which 2, 4 and 5 bottles of Y were manufactured in February was 1:2:3. Now in the month of February, according to this question, we have 30 days, and these 30 days will be divided in the ratio 1:2:3. So that means 5, 10 and 15 days respectively for 2 bottles, 4 bottles and 5 bottles. So total bottles which were manufactured will be 125. Now let us assume that number of bottles sold, 1 bottle for X days, 2 bottles for Y days and 3 bottles for Z days. Now manufactured minus sold will be equal to leftover bottles, that is 125 minus 3Z is equal to 57. This data can be taken from bar graph. So solving this, we get we have substituted y as 30 minus x minus z. So value of z is 8 plus x. Now question says that the number of days on which 3 bottles of Y was sold was minimum possible. That means value of Z is minimum. Now to minimize the value of Z, we have to minimize the value of X here. So minimum value of X will be 0, which will give me minimum value of Z as 8. Now if X is equal to 0 and Z is equal to 8, then value of Y will be 30 minus X minus Z, that is equal to 22. So the number of days on which 2 bottles of Y was sold in February will be equal to 22 days.